Hello friends, welcome back to the bench. Thank you very much for joining me. We have a 90, was it 93? I think it was 92 or 93, 2600. Doesn't really matter if it's 92 or 93. And we have a description of the issue. Actually, we don't have a description of the issue. What we need to do is just inspect it, rebuild it if needed, fix whatever needs fixing, and ship it back, because I have a Mazda that has been sitting for a long time. The previous owner said it needed a new ECU or distributor when it originally quit. It doesn't have spark or fuel. I realize it could be several issues, but I wanted to start with the ECU. Blah blah blah. So yeah, if there is no spark and no ignition, no ignition and no injection, well, this could be several issues, right, at the same time. This could be both the ECM issue and the distributor issue, and there's actually a huge list of potential problems. But as long as the distributor is fine and the ECU is good, you should at least have injection and ignition. Now the car might run rough, it might run well in open loop, but when it switches to closed loop, it starts misbehaving. Sometimes like misfires or rough running on the highways, or it idles. It idles well, but when you throttle, it starts choking, or vice versa. If it's on a high RPM, it seems to run fine, but it won't idle. It'll be shaking when it's idling. So a lot of issues. So let's just eliminate a few over here, replace what we need to replace. This has been already worked on, and the screws are in horrible condition. We're gonna have to clean those screws. I'm not sure why, but it looks like, I don't know, someone was opening this ECM with a nail file instead of a screwdriver. And we have a missing screw over here. So, I mean, it happens. Not to me, but it happens. Especially if you're like doing it in the mechanics shop, in the car repair shop. And now it's easy to misplace the screws because there's always going to be screws lying around everywhere. I mean, it kind of depends how well you take care of your shop, how well organized you are. All right, so it just kind of always depends on the technician. We have plenty of corrosion overall. So yeah, this car has been sitting for a while. So what we need to watch out for is not only a typical issues that we normally face on these, which is leaky cabs and corroded traces and stuff like that. But also, since there's so much corrosion, we have to inspect the harness, and we have to watch out for a cracked solder. Well, it looks like corrosion is kind of limited to the exterior. There's a little bit inside over here. I'm just gonna spray some WD-40 on it, let it sit for a little while, get a little bit of that rust off. The flux has not been cleaned, but this is rosin, so that's fine. And looks like the transistor was replaced. I wonder why. Okay, so first, let's do a quick visual on what was done before. So the cap has been replaced, obviously incorrectly, but we have no corrosion here. Usually this trace is completely corroded, this via, so not much corrosion. This is improperly restored via, which is fine. So looks like this at the time the original repair was done, this was caught relatively early, very early actually. Very little damage. It just wasn't done correctly, but it was caught early. So at least we stopped there. Here's some retracing, which does not look good to me, but who knows? It might be good. We have some green copper, so we'll see. This resistor seems crooked to me. I don't know if this was replaced. Yeah, it's a little bit crooked, which is fine. So maybe hot air was being used here, but no, I don't see any signs of hot air. Let's check the diode, because last time we had a faulty diode over here. This one's fine, and the reverse 2.8, beautiful. So Zener diode's good. This one's 2.1 in reverse, and I think this will be good as well. 0.7, yeah, okay. Yeah, so at least no problems with the diodes. So now, the transistors do not look very good, but first let's confirm that we have bases. We have connection to this one, and we have connection to this one. Okay, so transistors, or the vias going to the main injector transistors, are good. We're gonna check the voltage as well, but before we do, let's do the ground test. So base 27, very good, and the other base 27, 26, 27, all good. Collector open, and open, and emitter grounded, and second emitter grounded. So we have good connections here. So now let's check the collector, and oh no, there it is. Okay, okay, one collector is good, and the other collector is good. Okay, so our injection route seems okay. We're gonna check with the voltage in a second. So this should be good. Now this transistor over here, why is it looking like this? And this one seems like it has been replaced, or maybe it was just resoldered. Maybe someone suspected cold solder or something like that. No, it looks like it's replaced. Yeah, this transistor was replaced. Why was it replaced? Let's check. So we have bases on the right, emitters here, so we should have a diode here, and one of them, yeah, this one, that's why it was replaced. So you don't need to replace it. This transistor will read different, okay, on every ECM, right? Here we have 0.7, here we have 0.7, here we have 0.7, but this one will show you twice as much, 1.4, right? This is normal. If you remove the transistor from the circuit and test it outside the circuit, it's good. And that's probably what was done over here. Someone just removed the transistor to eliminate it being faulty. No shame in that. I did the very same thing when I first encountered this, and the reading was different over here. So I figured, okay, let's replace the transistor. Didn't need to. So this will be fine. But before we start cleaning and stuff, first let's confirm that we have no issues on the ignition. 1.3, 0.5, and 0.9. Beautiful. Now the base over here, and this trace sometimes gets damaged, but it's good. Sometimes this trace is gone. It's mainly somewhere around here, because usually that's where the corrosion is. We also have some signs of soldering, but that's probably just escaping flux. And just out of curiosity, let's remove the capacitors that were not correctly soldered on, but good enough. And out of curiosity, let's see if they still work at all. This took a long time to measure. The ESR is high, is very high, but not like the highest we've seen. V-loss is not super huge. Capacitance is a little lower, but it took forever to test. So that alone tells me that this cap is no longer good. You know how it is with the testers. I know the tester's not gonna tell you everything. Sometimes you have to go the extra mile to just kind of figure out what's wrong with it or whether it's good or not. If it's taking close to like 45 seconds to measure, then definitely that's not supposed to be happening. It should be a lot quicker than that. And this one measures pretty much the same. Are these 105s? Okay, these are the wrong caps. This is 47 but 63 volts. That's why we're measuring poorly. And at least it's 105, so could have been worse. It could have been a lot worse. I've seen 85s being installed here. Okay, so first order of business, we're gonna put it in the ultrasonic cleaner, let it soak a little, then give it a few minutes of ultrasonics. Now what that does, it just kind of lifts the conformal coating off the board a little bit, and then we just take tweezers and we just kind of remove the conformal coating in those little like layers, patches. Then toothbrush and a little bit of scraping, then a little bit of spraying, scraping, spraying, scraping until it is perfectly clean. Then we're gonna replace the cups, test it under power, and harness looks good, but we're gonna inspect it further, maybe put some deoxit on the on those pins. I don't see any greenish tint, so I think the corrosion never made it to the harness, which is good. Overall, this is a very nice condition. Very nice condition, just too bad the previous tech didn't do it properly, because then we wouldn't have this in the shop. There's some damage after replacing the cap. There's a little bit of damage. Nothing significant, but that shouldn't look like that. And looks like there is even a little blob of solder. Maybe not. Maybe that's just coating. That's why you remove it. And there is some flux left, so we know what kind of flux they were using. It looks like rosin-based. All right, let's speed up the footage, get it done, and we'll see afterwards. Alrighty, and we are done. Nice and shiny, looking like new. I didn't really see anything wrong with it other than those crappy caps, but I would think that those caps would still be working. So definitely it's a good thing to remove all that remaining corrosion and and seal it, obviously. I prefer this to be sealed, so it's resilient when it's high humidity, temperature changes and stuff like that. But the next on your list is the distributor. Distributor perfectly explains why you have both no injection and no spark. Because without the signal from the distributor, the ECM will not open the injectors. But everything here seemed okay, meaning if the signal from the distributor was present, this would be firing injectors. Now it could be, rough idle or stuff like that. It won't be now. But overall, it should have worked, right? I didn't see anything in the ECM that would prevent the injection from happening or ignition. So it must be the distributor. Once you replace the distributor, don't bother like fixing it. They're really not that expensive, and it's depending on the fault, it can take it can eat away 2 weekends trying to fix the distributor. So once you replace it, you will note that you should have some ignition. I mean, it could be weak, but it should be there. And you're definitely gonna have injection. But if it has like rough idle, or it runs better when cold or worse when cold, that kind of stuff, hit me up. I'll send you a nice little list of things to check. I have some lists already like pre-made because I diagnose a lot of these trucks. So usually by the symptoms I can tell where to start poking, because there's a vacuum system that usually is faulty, the muff, obviously, the airflow meter, the fuel, the coolant temperature sensor, all that kind of stuff. There's like a list of roughly 5-6 items that usually go bad on these, on top of the ECM and distributor. So hit me up if there are any other problems, but this should be good. Thank you very much for your business. Thank you guys very much for watching, and I shall see you guys in the next one.